let's take a look at my favorite way to solve these absolute inequalities, graphically. I love using the TI to do this because there's a lot of less chance that you make a minor mistake with all the cases and such. So I prefer to do it this way. See what you feel, and we'll go from there. Before we start, we'll start off with looking at part A and part B together. And the reason why they are the same exact, they have the related equation that is the same. It's the inequality symbols that are flipped. So when you interpret the graph, you could actually interpret for both of the solutions. So we'll go from there. I'm going to start off with the root zero method. That is my favorite way because the more I have inequalities, or the more complicated my functions get, it's a lot nicer just to have the root zero where you're only inspecting the x-axis. So we'll go from here. If we're going to use the root zero method, I'll highlight it as we're looking at this. The first thing we have to do for ourselves is understand what we'd be typing in for y1. And so when we do this, for y1, we would have to move everything to one side. And I think it's a lot easier just to move the 12 to the left side than it is to move the absolute value and the 7 to the right. So I'm going to go with that method. And when you move the 12 to the other side, you're actually subtracting 12 from both sides. Now you can do the math if you're interested. I mean, it's not that horrible, 7 minus 12. But I want to show you how the TI will take care of it for you. So we have the plus 7, the minus 12, still less than or equal to 0. Similarly, for part B, nothing has changed other than the fact that the inequality symbol is. So you can kind of see if we compare. For part B, we have 2x plus 1 in absolute value bars, plus 7 minus 12 is greater than or equal to 0. So this would be our case of the y1. If you would like to understand, anytime we're trying to solve these inequalities, usually the first thing we do is solve the related equation. So in both cases, the related equation is the absolute value of 2x plus 1 plus 7 minus 12 equals 0. So in all cases, if you're trying to name who your y1 is, it's always going to be the non-zero side. So whether or not you wanted to talk about the related equation versus the inequality. So in all cases, see how the y1 is the same for all three cases. So now that we have that, what we can do is pull up our TI. And we're going to type in for y1. So I'm going to clear out my previous settings. And I should be looking at the absolute value. So if we're going to type in absolute value, we're going to have to go to the math key. And we scroll to the right, one arrow over to number, ABS. We press enter. My calculator sees the bars, but if you have the ABS, just remember to close your parentheses when you're done entering what's on the inside of the absolute value. And we have 2x plus 1 on the inside of the absolute value. So we'll write that in, 2x plus 1. Then just double checking. I should have a plus 7 minus 12 on the outside. And if you're really interested in doing the math, that's okay. It won't matter because the calculator takes care of it for you. So we press enter and we can graph. And we see, I think I was in the standard window. So we see we have a clear function from here. When you do the root zero method, you are looking for the x-intercepts and the behavior of this absolute value function. It seems like we have all the x-intercepts we needed, so we have the appropriate window. What I would like to do for myself I will calculate these zeros, and I can sense, well, we actually did this analytically already, but I kind of see where the zeros will be, but we want to be clear to make sure. I think it looks like it's -3, +2, but we want to be clear because sometimes you could be really, really close to an integer and not be an integer. So let's just be clear about this second trace. We're going to calculate the first zero. I'll move a little closer to the one I care about a little bit more. And when you do left bound, a little bit higher than the x-axis, press enter. Right bound, move a little over to lower, press enter. So you're finding the bounds of that intercept. So make sure the two arrows are pointing at each other and your intercept is in the middle, or your zero. Make it guess, press enter. And we do have our first zero, x equals -3. And then second calculate, we'll do the same thing. Calculate another zero, move closer. So you can either use the arrow key, or if it gets too tedious, you can actually move it closer by typing in an x value. So press enter, move over to the right bound. This time the right bound's above, just the behavior of the function. The zero is in between the two arrows, so we press enter to make a guess, and we have -3 and 2 as our zeros. So that is really all we need from the calculator. What I want to do, if I were showing work, is I want to sketch this graph relatively accurately. So I'm going to go back to the work portion. And as far as my work will go, I may either put it off to the side because I maybe want to put the answers to part A beneath. So here's my graph. I'll do it over here. So a quick sketch of the graph involves axes. And you're relatively showing the most important parts. So when I'm kind of looking at my calculator screen, it kind of looks like the point of the absolute value. It's a little to the left of the y-axis, and then you could kind of see that you're intersecting the x-axis at two places. So we'll go back just to kind of see it. And I see that my y, maybe I don't know, call it the vertex is the point, but I'm doing something like this and something like this. So I'm relatively accurate. This is my y1, both sides, by the way. What you also want to do is show what your boundary points are. So I prefer marking them. And our zeros, I believe it was +2. We'll double check just in case. +2 and -3. So I mark where they're located. And then if you were solving the related equation, the solution to the related equation is your zeros. So it's not asking for it, but I know in the previous examples in this section, you would write it with braces. And those are the two values that make y1 equal to 0. But if we're looking for the solution for part A, I would like to have another color. There we go. We are looking for where y1 is less than 0. So what I'm trying to understand is my boundary points, -3 and 2, break the x-axis up into 3 different regions. And I'll alternate colors just so that we can see them. So your job is to pick the region where you have y values that are less than or equal to 0. And so if I'm trying to understand what this means, I might want to rephrase it. Y1 less than or equal to 0 would mean what values of x give me negative y values. Less than 0 means negative. So it's kind of like the question that I'm asking. So do x values in the yellow region or teal region give me negative y values? And what I'm going to answer when I see it right now, if we play a lot with section 1.6, any X value in the teal region, if you map it down, it's going to give you a negative Y value. Doesn't matter where you pick it. So we would be choosing the teal region, the values of X. And if you want to describe it as the solution for part A, and I'll label it so we don't get confused. If you're going to describe that region, it didn't really say use any sort of notation, but I like interval notation. So we're going to go from -3 to 2. And because we have the less than or equal to, we use brackets. And kind of compare this with the one you did analytically. Is it the same? It should be. It's kind of my favorite way to do this. Now, same story for part B. What's kind of cool about part B? It's the same inequality. In this case, we are looking at y1 is greater than or equal to 0. So if we're asking the question, we would say, what values of X give me greater than or equal to 0? Positive Y values. And when you're choosing, obviously it's not going to be the teal region because those are the ones that gave you negative Y values. It's going to be the yellow region. So those values of X. And if you're not sure, you could pick a test point in the yellow regions and kind of see like, oh yeah, but if I map it up to my function, I'm always going to get a positive Y value because the function's above the X axis. So the solution to part B, if we're going to describe that yellow region, -infinity to -3. We should have brackets. And we have a union from 2 to infinity. So this is hands down my favorite way to solve absolute value inequalities. I really don't like using analytical ways, mainly because I get mixed up with all the steps. So if you can read graphs, you can always figure out what the solution is.